let's talk about switch loops. I challenge you, comment down below where in the codebook it talks about switch loops. It does. It's a very small section, but it does mention the word switch loops. And again, in this video, we're going to talk about it. But first, I want to talk about wiring a regular switch to a light. In this instance, we have a home run with 14-2 cable. And as you can see, it goes to the switch box. And let's be clear, a switch does not utilize the neutral. Okay, so that's why our neutral just gets spliced to a wire nut and then it passes through to the light. But let's talk about the ungrounded conductor. As you can see, the switch, when it goes on the on position, it closes that circuit, allowing power to travel through the switch to the light. And again, in theory, electricity travels on the ungrounded conductor to the load, in this case it's a light, and then it travels back on the neutral. But again, for a switch loop application, which the code does allow us to use switch loops, it's going to be wired different, and let me show you how. Well, for a switch loop application, it's actually wired backwards, sort of, okay? So instead of the home run running directly to the switch and then to the light, a switch loop has the home run go to the light, or whatever the load is, then to the switch. And I'll show you how it is legal to do. It is in the code book. So again, a switch doesn't actually utilize a neutral. It is not a load. So my true neutral, and what I mean by that is the white conductor going directly to the source, to the actual ground. The grounded conductor is going to go to the silver terminal of my light in this case. Now, again, this is 14-2, so we have a black cable. Now, if I ran this black cable directly to the brass screw of my light, it would be on all the time, right? As soon as you turn on the circuit breaker, it would be on all the time. And we don't want that to happen. We want this light to be switch controlled. So it's going to pass through, okay? So now, again, 14-2 here, we have a black conductor and a white conductor. And what we're going to do, but with a proper code compliant switch loop application, we're going to take the white conductor, okay? So it is spliced to the ungrounded conductor from the source, so it's hot, right? It's going to go to my switch. And then from my switch, I'm going to utilize that black conductor of the same 14-2, and it's going to go to the brass terminal of my light. So again, power passes through from the source. It goes to the switch that is currently in the off position. We flip it on. It allows power to pass through and then to my light. So as you can see, this light is going to work like any other light properly installed. You flip the switch and the light turns on. You turn it off and it's off. Now, again, to code standards, comment down below if you found it, okay? We actually have to take this white conductor and label it black, okay? We don't want any future electricians to open up the switch box and see a white conductor and think, is that a neutral? We don't want them to think that. They have to understand that this is an ungrounded conductor, even though it is white by manufactured design. We have to tape it. You have to mark it with marker, whatever the case is, so that it's clear that it's an ungrounded conductor, not a neutral. So this is a switch loop. This is part 1. There's probably going to be part 2 and part 3 of the series. I want to wire it for you so you can see a visual of how this actually works. There's certainly more code to switch loops. And on top of that, some of you might be thinking, don't you need a neutral in a switch box? And you might be right. It is in code. It is not a contradiction, though. We are allowed to do switch loop applications, but I'll talk about that in part 2, part 3, part 4, however long this series is about switch loops. Thanks.